Okay, so this will show you what some of the goals are for folks today. A lot of people are using Python now as a excellent language for data science and machine learning, and it's used now throughout Microsoft technologies. And by the way, Microsoft's very pro open source these days. Microsoft has a distribution of Linux. About 44% of the VMs running on Azure are running Linux, and .NET is completely open source. So today's technologies with .NET and Python are open source technologies. And that means that we're always looking and contributing all together as a community to make these technologies better. All right, so today we're talking Introduction to NimbusML. My name is Mark Tabladio. I am a cloud solution architect, and I'm also a data scientist working at Microsoft. I guess the title got in there twice. And the office is US CTO Customer Success. And you can find me on Twitter at MarkTabNet. And a slide about me again in front of that same office. I have a science doctorate from Georgia Tech. My analytics career is based on SAS, Microsoft, and open source. Now, I was working as graduate business faculty, but I'm not doing that anymore. But I've done tech presentations in many areas. And you can connect to me. Feel free to connect on LinkedIn and Twitter. And again, right now, I'm a cloud solution architect at US CTO Customer Success. I'm sharing a picture today of Microsoft's Atlanta office, and it's in the facility called Avalon. There's several buildings there, and if you look at this building, Microsoft takes the top floor, which is the 9th floor of this building, and then half of the 8th floor is for employees. So that, the top floor and a half. And I'm mentioning that, and this little code on the side is about events at Microsoft, and not just at the Atlanta office, but worldwide. So if you want to see what's going on at Microsoft Office, what free things are there, click that code. Many of the user groups now in Atlanta area are meeting at this office, and we just find it very convenient. It's a large space. It's very well decorated. It's very inviting, open, well lit, and glass windows. Very nice office. And of course we share our facilities with so many other stores. You see that a store that's right down at the bottom here, that's an Apple store. And I have an iPhone. So I could always run downstairs and ask some questions about my phone, if I happen to be there. I work from home, but many times I'm also at the Microsoft office with clients, or certainly free to work here at our wonderful facility. These are some of the companies that are using Azure for ML and AI as we pivot into today's topic. Many people are already using technologies now based on ML and AI in the Azure space. And as Microsoft's rolling out more capabilities, and especially for open source technologies, the interest is growing in this topic. This slide here has an overview of what is available for machine learning on Azure. So if you just scan the slide, you can see many of the technologies that you know. You can see Jupyter, you see Onyx, TensorFlow, PyTorch, and machine learning VMs, Azure Machine Learning. Today we're going to focus on Azure Notebooks, and that's going to be in that second row. And of course you can see we have the ability to run solutions on CPU, GPU, FPGA. Now, not every combination of everything is possible, and some of these technologies are optimized for certain types of workloads, and that has to do with understanding what the options are. By the way, today's presentation is going to be the third of 4 presentations. There's going to be another presentation in the next hour. I will show you the link at the end of today's presentation for that next talk. The agenda for today is to look at NimbusML, secondly to do some demos, and third to have some action steps. So what is NimbusML? Provides state-of-the-art ML algorithms, transforms, and components aiming to make them useful for all developers, data scientists, information workers, helpful in all products, services, and devices. Long sentence, I should have trimmed that one. The components are authored by the team members as well as numerous contributors from MSR, meaning Microsoft Research, CISL, which I don't know what that is, Bing, and other teams at Microsoft. And NimbusML is interoperable with scikit-learn, estimators, and transforms. Now, this is the first interesting point. It's interoperable with scikit-learn, estimators, and transforms while adding a suite of highly optimized algorithms written in C++ and C# for speed and performance. What we're going to see today, we're going to see compare and contrast. We're going to see some scikit, then we're going to see scikit plus NimbusML, and then we're going to see a third pipeline with just NimbusML. And they're going to be comparison and contrast. These are going to be notebooks and code that you can run today. So you will see that by the end of today's presentation. What is the value proposition of NimbusML, and especially if you're using scikit-learn, and we're not saying don't use it. We're just saying use this when it's better than that. Use this better when it's better than that. So people who are now experts, and if you might be an expert already in Python and ML, and you want to chase this topic, and you want to know what the difference is between the two technologies. So let me make sure I'm on the right slide because I touched my mouse. Okay, NimbusML trainers and transforms support the following data structures for the fit and the transform method. And so you can see here, those are the data structures. And also supports streaming from files without loading the data set into memory, which allows training on data significantly exceeding memory using file data stream. So with file data stream, NimbusML is able to handle up to billions of features and billions of training examples for select algorithms. I'm noticing there's an English mistake there, which is in the source document that I got this slide from. So there's another performance claim here. It's not always important to read into memory. And that is already now, to me, an advanced data science and machine learning point. It's not just about building models, but what do you do when you have a data set that is so large? What are some of your options? Here's another option. All right, straight to demo. How about that? All right, so what I have done, and you'll see this on the screen, we are looking at Microsoft Azure Notebooks. Notice that this technology still is preview. I'm showing it in Notebooks, not that this is where you will build and deploy it, but this is where I am demonstrating it. And the reason I'm demonstrating it here is because the authors of today's demos and talks suggest to use this technology to show it or to demo it. It is not the only notebook technology in Azure. You can run Jupyter notebooks from many different places, and you also may be able to do some remote submits or other types of ways to run workloads on places other than where the notebook is running. So that means that notebooks could be running in a data science virtual machine, or could be running with Databricks or some other technology. Today, and for this presentation, we are in Azure Notebooks. And I've copied two sets of presentations. We're going to go through what we can, and we're going to start with this one called NimbusML presentation. And I've already have it loaded here. It says here it's cloned from this GitHub repo and from this guy, Gani. So, and I'm hoping I'm pronouncing his name right, but he's the one that developed this presentation. I think it's excellent. And of course, it's now on GitHub. You might not know about it, and hopefully this is something new for you. He is a principal software engineer at Microsoft out of San Francisco, and we're going to look at his material. So first is the installation. And I'm not going to explain Jupyter. I'm going to assume that you can go study what Jupyter does later, but it's a technology that works in the browser, allows one to run code. And what we're seeing here are some commands. Now, I had to change some of his commands because what happened was, if I go down here, his first command had to do with upgrading NimbusML. And let me see here. Okay. What's important is on the upper right corner, it shows what the kernel is. And you see right here, the kernel that is running this is Python 3.6. Now, when I am upgrading a kernel or an environment really for Python, and I'm using, for example, maybe I'm using Linux or maybe I'm using Windows, and I need to update the packages, I'm normally doing it from the command line. There may be a way to do command line updates to the kernel behind Azure Notebooks. I do not know what that way is. So this command here, import sys, and then also a system executable. What this command does is it upgrades or installs the NimbusML software into your environment. And it might not be, when I say your environment, I'm talking about the kernel. All right, so let me use the consistent terminology. And when I did that, and you can see here, there was a mismatch in the packages. Therefore, I went back and then I started doing it, other updates, first to Azure ML, train AutoML, updating that, but that's really not enough. I had to do upgrade Azure ML-SDK. This may be what you have to do, I don't know, but these technologies all work together, so the Azure ML needs to be updated so that it matches the NimbusML implementation. And once it is in that kernel, then it's going to be there, not just for this project, because the Azure Notebooks work on this concept of projects, not just for this project, but the other one, which comes from a different repo, can run on that same kernel, which has already been updated. Okay, so that's just to say that we have the right packages already installed, and then once you check the version, you run some tests, you make sure that you're getting some output that implies NimbusML is working. That is what the point of this notebook is. So again, this is all being videoed, so you will be able to see that later if you want to study that. Close and halt. Package management is a major thing. As any of you know, we've been running Python. You need to know what version you're on, what kernel you're running, what environment, what packages. It's part of the price. Okay, so now that having done, making sure that the packages are loaded, now we're going to talk about why we are using NimbusML. Why are we using NimbusML? Why would you want to do that? So look at this. This is such an excellent notebook. It's giving me nice large graphics. Full power of ML.NET. Now, here's a claim, 5 to 100 times faster versus scikit-learn. Streaming when data is greater than RAM. And that, I said that earlier, it's important to know that you and I may not have enough memory. So there are many ways to handle that. This is another way. Another way is to stream the data into the processor. Okay, third one here, benchmark winning algorithms. And how we know they're benchmarking is because the algorithms inside ML.NET come from many Microsoft teams that have refined these algorithms over the years. And so they know what the benchmarks are because they are motivated to make them run quickly. And then cross-platform, Win, Mac, Linux. Why is it cross-platform? Because of .NET Core. .NET Core allows ML.NET to run on these other technologies. Python-friendly APIs, so the familiar APIs to scikit-learn users can read from pandas data frames and seamlessly work with scikit-learn. You'll see code today. You will be able to run code after this presentation. But this is a 5 to 10, 100 times faster than scikit, and then just some graphics here kind of showing that. Okay, so let me see if I want to rerun this or not, and I am not going to rerun this. So I'm just going to go with the run I already had. It's going to import pandas, and you see on the left side, import scikit-learn, and then NimbusML. Setting up a training and test data set, and this is a Kaggle Twitter positive negative sentiment prediction, just used as a dummy data set just to illustrate the merit of NimbusML. We have a label column, a feature column, training and test set. and that's what you would know from knowing data science. Scikit script here, and that's running, and it runs to an accuracy of 0.778. That's the accuracy score. That's the scikit script. Now, second one here is we're going to replace that scikit with a NimbusML learner. So it's going to be very similar. If you see the code here, let me just see if I could show both of them at the same time. Yes. So here's the first set of code. This was scikit-learn, and here's the second set here with NimbusML learner. You can see they're very similar in their setup. Let me see where the difference is. Okay, right here. Fast linear binary classifier, as opposed to like SGD classifier. That was the only change of the two lines. Okay, the output, slightly different. Accuracy, 0.792. And also elapsed time. I don't know if they had the elapsed time. Oh, you know what? Elapsed time was built in. So that's why, because I'm looking for a time command and there was no time command. Could put a time command, you know, if you're in Python, just go get a time command, put it in there and see how long things take to run. If you need to look up fast linear binary classifier details, here's the extensive doc. And TLC, you will see, and this is an advanced comment, internally, Microsoft had called this technology TLC. It has since now been put into ML.NET. So those two things mean something very similar. Okay, here's the high-level architecture of what happens within, and notice this is all within the Python exe. So we got Python here, we got a bridge, C# and C++, and then TLC, ML.NET. TLC refers, I think, mostly to the algorithms, but ML.NET is that plus whatever is also being added to ML.NET. So I would think of TLC as a subset. That's my thinking. I might be wrong, but that's my current thinking. Okay, so this is the high-level architecture. Now, finally, this is the third variation. So this one here is the optimized NimbusML script, where NimbusML takes control of the pipeline also. So the difference is not just the algorithm, which is here, fast linear binary classifier, but also the pipeline, and this accuracy 0.806. Why? Because the pipeline is going to have some automated technologies to affect the features. That's what the difference is. So that's what the difference is between here, and here is a summary graph. All right, so here's a recap. What we did is created a simple scikit-learn script, use NimbusML learner and scikit-learn pipeline. That's this one. So this is the first, this is our baseline. And then secondly, scikit-learn plus NimbusML. And you see those yellow lines are the difference. And then finally, it's just NimbusML. So instead of using the scikit-learn pipeline, just using the NimbusML pipeline. I'm going to close this and go to the next one. We're looking at the wine tutorial complete. All right, so the tutorial here is how much is your wine? And what we're going to talk about in this one is NimbusML pipelines, file data stream, which is that technology so that you don't need to read it all in the RAM, and column operations and rows. So here's the start. All right, the modeling data can be sourced in several different types, and this is a simple example here of that type. We can also use pipeline to include more than one operators in the model, just like scikit-learn. So again, similar setup to scikit-learn if you're already using that. And what I would do is, if you were considering using NimbusML, do comparison and contrast. Start with a small data set, compare on both sides, see if it's providing an advantage. And even if it's just giving you a boost over the native scikit-learn, and you know that there might be some advantage here. So in this section, we're trying to develop a prediction model to use review data. So this is about wine reviews of the wine to predict its price. And we will use NimbusML's text featureizer to extract numeric features from the review corpus using pre-trained language models. So the data set here contains a mix of numeric, categorical, and text features. What I like about this example is it's closer to a real-world example and having a number of different types of features. So it's implying here how to handle when one has mixed features. Why is that important? Because this pipeline is processing the data, and it's going to use its own transforms, as we're going to see on a graphic. There's going to be a graphic in here that shows exactly what happens. Data preprocessing is a stream data from files. So here's where import file data stream is coming from, and that's it. So it says here we don't use pandas data frame, but we're using file data stream to improve performance. So that's what that goal is here. And as we get to that DS train data set, show the schema, and you can see what the schema is here of the features. There's not a lot of features. I mean, this is still a demo data set. I'm looking here between 10 and 20. Many of the real world projects I do sometimes will have this many features, but more typically, and especially if you use window functions, and for that type of a data set, could get into the hundreds of features. But this, again, this is a demo. So here we're just importing a picture just to have a picture here in the graph. And what it's showing is that some of these features are going to have the one-hot vectorizer, and then there's going to be a count selector. And then there's a description, which is a text field, and that's going to go through the n-gram featureizer. And then there's another one called word embedding. And then some of these here, this price shows here a filter. So that's a numeric variable that's going to be filtered and then presented to the regressor. So what's showing is that depends on what type the variable is, it's going to have different types of transformations that happen. So that's what's happening here. So down here, we have country, province, region, one, variety, and those are done through the one-hot vectorizer. And then we go through the text, and then that does that point, and then there's the numeric ones. Some of this is commented out. I haven't studied this in detail, but I would always look at the comments to see what some of the variants might be, or some of the comments could imply. These are warnings, and warnings having to do with some issues that might be in the original data. Two choices. Obviously, a warning is not necessarily a stopper in any software context, but you might want to go back and fix that with source data with some additional ETL if that is an issue. Illegal quoting to me means that mismatched quotes. That's what it means to me. And could be, but my mind's open, because so it's not just the double quotes, but also the single quotes could refer, even in some people might consider parentheses quotes or the brackets, or the pointy brackets. Maybe they're not matched. Usually it means the double or the single quote. Okay. So here's some more information. Users can specify the input columns for the transform using this notation or this notation. So there's two different notations to specify the transform. Which one do I like? I mean, I'm looking at these both and I'm like, I kind of like both. I actually like the longer one, usually because my use case is leaving the code for somebody who's got to come behind it. So I tend not to take shortcuts in code that I leave behind for other people. I tend to spell things out, not use abbreviations. spell out acronyms, and so that's just my programming style. Now, here's the interesting thing. I think this is the natively done picture. So there's a utility inside NimbusML that will make the picture for you. That's what this is. So it shows here, this is the original row that represents all the features, and then it shows what type of transforms were applied to those features. So very similar graphic to what was in the other graphic. All right, so now it's going to go to model valuation. And so you see the model here, R squared, because I think this one was a price, if I'm remembering, but we're doing a regression. Okay, so this one here, so the first graphic is the natively done graphic that comes through Python. The second picture has, let's see, I think there are some notations on here where they put some other comment. No, that's not this one. Sorry. So this is a stored graphic. So let me see what the difference is. Oh, okay. So this is slightly different than the other one. Country. Huh. Maybe there's two. It just did it two different ways. The live GMM score could be because of the versions. I don't know. But the graphics, I think, are the same. I'm going back and forth. But recap. So in this tutorial, I present an example to use the NimbusML pipeline, train the model with the file data stream, and the column operation for transforms and learners. So for transforms, only use columns. For learners, use specify roles by using the feature and the label. So that's what you need for when you have the model. And then there are docs that will show how to do that. And I'll show the docs because I have not shown it yet today. But this is the documentation for NimbusML. I believe there is a link later in the deck. And it gives you some information here, including you look on the left side, the installation guide, the tutorial for classification and regression. There's also some more examples beyond just what I'm showing today about other types of concepts for NimbusML. So this is the second one. All right, there's 3 notebooks in here. So I'm going to close that one. Go back to the screen in here, show part 3. So here's part 3. Part 3 is Spider-Man versus Superman. This is going to be image classification with pre-trained DNN, an example of cross-validation. So that's the third one here. What I like about it is because this is deep learning, this is transfer learning on a pre-trained model and adding some new images of Spider-Man and Superman. So a bit of a fun example. I've literally done the hot dog one before as a lab, made a lab. Transfer learning is a topic inside deep learning. I'm not explaining it today, but if you're already doing deep learning, then you'll find this one interesting because now we're going to do pre-trained DNN models with NimbusML. So NimbusML can use any TensorFlow or ONNX pre-trained models. And ONNX, of course, is that cross-industry standard supported by Microsoft and so many other companies to share neural networks. And we'll probably be seeing more of ONNX in the future. Certainly would love to have people show examples or consider using that in your production systems because it is a transferable format for being able to use those same models. Today, 2 examples we will look at today are AlexNet and MobileNet, which are trained on ImageNet to ID images as one of 1,000 different classes. We can adapt them with transfer learning to classify images into specialized classes that we care about. And the classes today are Superman and Spider-Man. And here's a graphic of a picture with Superman and Spider-Man. Pre-trained DNNs files are large. They're not part of the NimbusML package wheel file, but they can be downloaded. So here's cool downloads. I love the way this whole demo went. So kudos on this whole notebook. For this tutorial, we've picked superheroes because they're not in ImageNet categories. Also, Superman and Spider-Man both have red and blue costumes to make the detection harder. So this is going to be tough. This is a tough problem. And when you see the output, you know, I've seen so many transfer learning examples where they have super high accuracy. And because, again, red and blue are part of the challenge here, it's going to make this image detection problem a little bit tougher. So let's build one. So this is the exploratory data analysis, loading data and the cells, and we can see the counts here. Is Superman, D-type, and I see 155, and I believe that's the number of images that are in the set. So here are some sample images. And so we see some images here of Spider-Man, and we see some images of Superman. And they've already been tagged. So here we're preparing the training and test data set. So 155 was that number, and I think there's 155 of each. So when I say, is Superman 124, 124, yes and no. So that's going to be, 124 of Superman, 124 of Spider-Man, and then there's going to be test data set 31 and 31. Okay, feature extraction with pre-trained DNNs. So here's where we're doing the transfer learning. If this is a new topic to you, I would recommend looking at a video on transfer learning. I don't have one to show or recommend right now, but that is what's happening here. The basic idea is taking the last layer off and adding your own new images and then being ready for that. So that's what we're doing there. Okay, now after we do all that, now we're going to evaluate the classifier performance. Let me see if there's anything on NimbusML that I wanted to comment on. So I'm coming up here. You notice that it's using the NimbusML pipeline, linear model. It's going to import logistic regression, fast linear, and average perceptron binary classifiers. And then there's an ensemble, feature extraction, pre-processing. So there are a number of functions here from NimbusML that are used in this example. Okay, choosing the final classifier. Now right here, it's choosing logistic regression binary, but it says try changing this to the other two. So I'll leave that as an exercise. How do you change it to the other two? You just change this line and then run it again. See how it does. Prepare and clean the data. Right now, this one is not trying to choose among them, but it's just trying to use the different ones. These algorithms, again, are part of the TLC technology that I talked about earlier. So that's loader. It's going to resize, pixelate it, make that pipeline, added the pre-trained model here, remove the extraneous input columns. The image path is an extraneous column you don't want to be part of the model, and then train a binary classifier. So then that's what it goes here. And there were some warnings where it said certain images were an unsupported pixel format, but it's going to convert it there. And again, if these types of automations are unacceptable to you, you may need to pre-process the data before it gets here. That's it. That's the answer. Evaluate the classifier performance. So we're going to look at the output. Now, this is an image of Spider-Man. And as this algorithm goes, what we're doing is we're looking for a score that's low for it to be Spider-Man, because it's all done with 1 being Superman. So 1 is Superman, 0 is Spider-Man. So that's Spider-Man, and it did identify that one as Spider-Man. So now it's going to run on the full test. That's just one image. Now it's going to run on the full test set, and then it's going to give some accuracy results. AUC at 0.75, accuracy at 0.64. And what I think is cool here, this is a cool example of showing people what does accuracy of 64% mean in visual terms, because we're about to see some pictures. There is a confusion matrix down here. You can see it. It's really tiny, 16, 15, 7, and 24. So you can see 16 and 24 were correctly identified, and then the 15 and 7 were incorrectly identified. And then we have this output. And in this output, it has a mini gallery of images. It has their numbers. And of course, again, this first picture is Spider-Man with a 0.01. That was correctly identified. But here was a picture of Superman. It says 0.25. That was incorrectly identified. And because it was incorrect, it's got a red box. So everything on this panel with a red box around it were ones that were incorrect. And you can see that was done here with the command flag mistakes equals true. So that's how that graphic was made. So overall, a lot of these were correctly identified. You'll notice in a lot of these pictures, there's a lot of red and blue in every picture. And it's confounded too by the blue sky, because a lot of these have blue sky. Not all of them, but a lot of them do. Okay, so here's view mistakes. So this is when Superman was classified incorrectly. But we look at 0.495. I mean, that's almost 0.5. That's pretty close. That was not, that high. But the worst one here was 0.25. And something about this image, made it not identify Superman. I was thinking too, maybe it's going to help the training engine just to focus on unique parts of each character, like the logo, and add those as additional images. That was my idea of improving the image detection. Spider-Man, okay, again, this is where Spider-Man was incorrectly identified. Ones that are close to 0.5, like this first one here, 0.55867, well, I mean, that's close to 0.5. And by the way, this looks like the first test image. It is the first test image. And maybe I just read this wrong, because 0.558671, I just read it wrong. Sorry. That was incorrectly identified. So this second one here, 0.7392, and all that. What is unique about Spider-Man in this case is his mask. So again, if you could do different photos, like to even take this same image and make a second image just focusing on the mask, then I'm thinking the engine might do better. I don't know that it will do better, but it's one thing I would try, to try to get just the parts, because what happens is whatever's in the image becomes the feature set, quote unquote. And if you have parts in this image, like just this first image here, if you have parts in here that are not part of the unique distinction between Spider-Man and Superman, it becomes part of the training. Not meaning that I wouldn't use this whole image, but that I would train a second image just focusing on the face, or trying to find that facial mask. Or maybe we could get somebody to write kind of an object detection and identify Spider-Man's face and put it as a separate image into the training, so that when it comes to identifying Spider-Man as a unique superhero, then that would be part of it. Now, maybe somebody's already come up with that idea that I'm sharing right now, and if there's such a name, that would be cool. But I've done these image classification problem demos so many times, and it's important to try to get the distinctive features trained into the algorithm. In this case, I'd argue it's Spider-Man's face. Second thing, and I know some of you may be already thinking this comment. When I looked at some of these images, there have been so many variations of both Spider-Man and Superman's costume. This one focuses on certain ones. So again, Spider-Man has had this costume, but the Spider-Man's also had different colored costumes. And it seems like every time they do a new movie, they have to slightly change the costume again. So that is, a challenge. That is a challenge. And you know what? It might be types of Spider-Man from different movies. So here's a recap. We introduced transfer learning and how to use it in NimbusML and built a Superman and Spider-Man image classifier without any deep learning or image processing knowledge requirement. I'd say that's true. It does help to understand it more, like the discussion I just had here about how the algorithm may be looking at the training images. So while it's true somebody can run this code, I would still, if it's for fun, and even maybe if it's for school and even for graduate school, maybe you can get away with not really understanding it that well. But I know definitely for commercial application and, if you're developing what I call custom AI or custom ML, where you're trying to get a competitive advantage, yes, you have to understand it. Okay, so that's my thinking on understanding. Okay, so we are now here toward the end of the talk. We have a question and answer box at the bottom, so feel free to ask questions in there. I'm going to show the beginning of the other presentation. This is just the NimbusML samples. Clicking there, you can see that there's numeric classification, regression, there's some sentiment analysis examples, syntax for column selection, learning to rank with Microsoft Bing data, that's an example, image processing, and visualizing the pipeline. We did see visualizing a pipeline, we did see image processing, we saw a regression example, and we saw classification. So we did see a lot of this, even though this second example has a lot more variations. So, and I think to me, the interesting thing too is this file data stream. So that might be one of the takeaways, that there are different ways to think about processing data, and especially with limited resources. I mean, I'd love to be able to always spin up distributed clusters and run everything on Spark. But you know what? That might not be an option for what your use case is. So this is another way to consider loading data sets, and something you can test. You'll have to test it locally. There's not going to be a promise that that will always be faster, but it is an option. And then also, again, NimbusML is not necessarily a competitor. It can be combined together with scikit-learn to improve the performance or efficiency of your process. Okay, let me go back to the slide deck. There's a question here about unsupervised learning in NimbusML. Let me go to, where do I want to go? Here. Actually, it's not going to be here. You know why? Because this is not the ML.NET documentation. We have to go to the ML.NET documentation. Actually, it's linked down there. Bam. Because what is in ML.NET is available in NimbusML. Same thing. So let me see what it says. Algorithms. That's just describing them. Matrix factorization, k-means, principal components. So I'm showing here the ML.NET documentation. A trainer is an algorithm and a task. So there's some linear algorithms, and you can see what they are here. Decision tree, this is what you get. Matrix factorization, meta algorithms, one versus all or pairwise coupling, k-means, principal components analysis, and naive Bayes. Now, this is for using NimbusML, and as I earlier said, one may want to use the scikit-learn algorithms. One thing I do not know the answer to, this is a question I have, can use a scikit-learn algorithm inside a NimbusML pipeline? Don't know the answer. I will show you too another thing. Doesn't show on here. Let me go back to my deck because I'm pretty sure I made a slide. So there's two sets of demos. The first set is what we went through, and it has the wine example and also the Superman, Spider-Man. The second set has, it comes from the Microsoft documentation, many of the same ones. Now, let me go to this slide because I'm going to suggest some other ideas here as we're wrapping up. Enterprise training and deployment. I gave a presentation about training Python scikit-learn models on Azure. And this was using multiple machines, and I think it was like 100 runs. I did it as a series, and for this virtual group, the left QR code is the slide deck. The right QR code is the video. So if you want to see how to do that with Azure ML service, take a Python model and train it on many machines. Okay, that's what that is, links about. And it works using containers. For deploying ML models at scale, now the idea now is to go to containers and have that available using the cloud. Maybe it's on the heavy edge, or what we're also calling the light edge. There's a heavy edge, which might be a machine. A light edge might be a small device. And those options are important. Okay, so here is this is a way to deploy. You can use Azure Machine Learning, go to cloud, go to heavy edge, and maybe go to light edge. Azure reference architectures, I did not talk about how to use Azure effectively. There's a whole set on that. That's just to show you that there is such things possible. Action. The NimbusML documentation I showed today, and I didn't read through all of it, but there's some important concepts to go through to understand how it's using that. Two of the concepts are the pipeline, and then also it's how it's handling the data sources. You know, we saw it with the file stream. And the NimbusML on GitHub, and this is where I got some of the examples. And the important thing here for Gitter. Gitter is a technology to ask questions about ML.NET. Now, because NimbusML is joined to ML.NET, you can ask your questions just like the one I just answered about the unsupervised learning here. And in fact, I noticed even from yesterday, someone asked this question about Keras, running Keras in ML.NET. It's answered here. I'm not even going to read the answer. If you want to know that answer, go here and see what the answer is. And also the answer about, does this work with GPUs? That was asked yesterday, and that'll be there. Now, we are going to have another talk. It's going to be in 5 minutes. And if you want to go to the next talk, go to this link. Now, I know I'm getting a question here. When can you get the PowerPoint presentation? Thanks for asking. I will be sending follow-up email to folks about where that presentation and YouTube's going to be. We record this presentation, but we have to do some post-production. I still have not done the post-production from yesterday, but I will be posting the slide decks to my SlideShare, and then also the YouTube, which is the videos, will be posted to our past data science virtual group channel. And so you should get an email on that. If you don't get an email, go ahead and ping me on especially Twitter. And I think I'll even announce it on Twitter. I mean, why not? I'll just announce it on Twitter also that where the presentations are, and do that all at the same time. Of course, I have to do it sequentially. I can only do one thing at a time, meaning Twitter, then email. But certainly would like you to have that presentation. The next talk that's coming up in 4 minutes is going to be about automated ML, and we'll focus on Azure. So again, it's going to have different demos than what you've seen. If you've been with me for the previous 3 talks, you know, 2 yesterday and this one, then you will see something new. And I'm calling this set the double-double. Double-double is 2 days, 2 presentations in a row, and double-double header. And this technology now is got enough new things that merited doing it in several talks rather than trying to cram it all into one. So thanks for attending today. I'm going to stop the recording.